Hello dear students. Hello. Good morning. Good evening, students. So let us start today the optical isomerism. So there is small technical issue. Let us continue. Yes. So optical isomerism. So what are optical isomers? Right. Isomers, you can write definition. Isomers which can differ in rotation of plane polarized light. Plane polarized light. So they are called optical isomers. So what are optical isomers? Means isomers which can differ in the rotation of plane polar light. They are called optical isomers. So what is plane polarized light? Let me give idea about plane polarized light. How do you understand it is? Plane polarized light. So what is it? This is simply we can call it as PPL. So the light which passes in one plane. One plane is called plane polarized light. How do we get this plane polarized light? Suppose normal light is there, normal ordinary bulb. Being like this. Now there is a filament which emits light in all directions. Like this. Now if this light is traveled passing in one direction, which is I placed one nickel prism in the path of this. So this is called nickel prism. So then the resulting light which travels in only one plane. Now this is called plane polarized light. This is called plane polarized light. Plane polarized light. So now this plane polarized light, so when we pass through a compound, this PPL, so we are passing through sample of organic compound or any other compound. So then what happens here? So PPL, this compound can change the path of PPL. So then this compound is said to be optically active compound. Optically active compound. And if not, if PPL path is not changed, then compound is optically inactive. Optically inactive compound. So on this experiment, compounds are classified into how many types? 2 types. What are those? So compounds can be classified into 2 types. What are those? Optically active compounds, optically inactive compounds. So we can write here compounds classified into optically active, optically inactive. So optically active and optically inactive, right? and that phenomenon is known as optical activity. So if can change the compound, the PPL path into other direction, this phenomenon is what? Optically active. You can say optical activity. Optical activity. Alright. So these are optical isomers. So these are called optically active compounds. So what is the condition for optical activity? Condition for optical activity. Yes, what is the condition for optical activity? So what is the condition for optical activities? First one, say chiral center. Chiral carbon. So what is chiral carbon? How do you write chiral carbon? So chiral carbon is a carbon which is attached by four different groups. Four different groups is called chiral carbon. Chiral carbon. So carbon is attached by four different groups is said to be chiral carbon. Suppose if you write it as like this. Suppose there are four different groups, so I can attach here chlorine, bromine, iodine, is hydrogen. Right? Therefore, how many chiral carbons are there? So four different groups are there, like chlorine, bromine, iodine, and hydrogen. So therefore, this is chiral carbon. So this is chiral carbon. Therefore, molecule must contain chiral carbon, that is denoted as C star, like this. Now, how do you identify the chiral carbons? Example, if I give mark the chiral carbons in the given compounds. chiral centers in following compounds. So example, CH3. CH3. Cl. So do we have any chiral carbon in this given molecules? Let us check. Here this carbon attached with the 3 hydrogens, this carbon attached with 2 hydrogens, this carbon attached with 3 hydrogens. So has no chiral center. Has no chiral center. Here it is how many chiral centers? Here this is chiral carbon because this part is CH3, this part is C2H5, this part is chlorine and other part is hydrogen. Therefore this carbon is chiral carbon. And here in this molecule has no chiral carbon, right? Therefore among these three, which is optically active, so this second molecule contains chiral carbon, therefore it is said to be what? An optically active compound. Optically active compound. Understood? Yes. So this is a basic condition for exhibiting what? Optical activity. Right? So similarly, what is the second condition? The second condition is chiral molecule. Chiral molecule. So what molecule is said to be a chiral molecule? So chiral molecule which does not contain plane of symmetry. Which does not contain plane of symmetry is a plane of symmetry. So on the basis of this, so molecules are classified as two types. Symmetric molecules and asymmetric molecules. Symmetric and asymmetric molecules. Symmetric molecules means they contain plane of symmetry. Have plane of symmetry. Here do not have plane of symmetry. Do not have plane of symmetry. Right? So the chiral molecule, simply what is a plane? The plane is imaginary true. Plane of symmetry is nothing but, how do you understand? So imaginary plane plane which can bisects the object or molecule. Molecule into two equal halves. Into two equal halves. So that is said to be what chiral molecule. Example, if I write some uh, simple example to make you understand. Write your example. Here it is. Like if I write letter A, yes. Can we divide the object into two equal halves? If I write letter C, if I write letter K, letter if I write here P, P. So in these three or four letters, if you say, if you pass imaginary plane like this vertically, like this, if I pass plane like this, so this half and this half mirror images. If I pass plane like this, and if I pass plane like this, so these three contain what? Plane of symmetry. And here this P does not contain, we cannot divide into two equal halves, right? So has no plane of symmetry. No plane of symmetry. So these three have plane of symmetry. Understood? So on the basis of this, we can divide the molecules into symmetrical and unsymmetrical molecules. So on the basis of this, the molecules are divided into symmetrical and unsymmetrical molecules. Right? So do remember, the molecules, chiral molecules are all chiral molecules. Molecules are always optically active. So chiral molecules are always optically active because no plane of symmetry. Yes. If you take some examples. Examples. Tartaric acid. Tartaric acid. So tartaric acid structure you can draw like this. So this is H, OH, so H. So this molecule, if you observe clearly, so there is a plane of symmetry present. It's a plane of symmetry. So that means what? The first half, if you put mirror, in the mirror it reflects like this. That's what this compound is said to be, has plane of symmetry. has plane of symmetry. Therefore, this compound is said to be which compound? Meso compound. Meso compound. And and this is called mesotartaric acid. It's called mesotartaric acid. And if you take other compound, active form, COH, and so here it is H, this is OH, right. And if you see it, there is plane of symmetry is absent because this half and that half are not mirror images. And if you take other example like COH is there. If I write its mirror image, COH, then we can write it as OH, and this is it is OH. So these two are mirror image to each other. So these two are called, they have no plane of symmetry. SAR EAMCET classes free anta on free amma free classes. Yes, free, you can access these classes, na? Free classes, free access only. Hi Lokesh. So if you see it, these two have no plane of symmetry. No plane of symmetry. Therefore, they are active. This is a inactive compound. Inactive. Hi Lokesh. How are you? These are active compounds. Okay, no problem. You can prepare for EAMCET. Active. So in this case, these two are called enantiomers. Pair of stereo isomers mirror images which are non-superimposable. Pair of mirror images which are non-superimposable mirror images. They are called what? Enantiomers. Used one term, this is called enantiomers. So if these compounds, if you take equimolar, then I would like to give you a racemic mixture. So racemic mixture, the term so what is racemic mixture? So you can say equimolar mixture of enantiomeric pairs it's called racemic mixture. Equimolar mixture of enantiomeric pair is called racemic mixture, right? So racemic mixture is optically inactive. Is optically inactive. Why it is optically inactive? This is important point. It is due to external compensation, and this because external between two molecules, if you put a mirror, then they are optically inactive because the reason now this is it is inactive due to so meso compound is optically inactive due to, we can say, sir, what is your saying that topic of chapter in first year, Namma? Sir, will you please repeat the topic? Yes, yes. So it is a first year topic, isomerism part we are discussing. Lokesh, is a first year topic, isomerism. It is due to internal compensation. So external compensation and internal compensation. This is important thing. Internal compensation and external compensation. External compensation. It is important for entrance exams. These two. Entrance point of view, these are important. It means what? What do you mean by external compensation? What is mean by internal compensation? It means, suppose this molecule is there, this half, first half of this molecule rotates the plane polarized light clockwise direction, and other one rotates molecule anti-clockwise direction, isn't it? So on the basis of this, we can say, suppose if you say like a optical active isomers, we can classify it into two types. Two types. What are those? Dextro and levorotatory compounds. Okay, write in big letters. Sure, sure, Lokesh. Dextrorotatory compounds and say levorotatory compounds. Levorotatory. Dextrorotatory compounds. Rotatory and levorotatory compounds. What do you mean by dextrorotatory compound? That means a molecule which it rotates. I can write rotates the PPL, plane polarized light, rotates the PPL towards clockwise, and here rotates the PPL towards anti-clockwise. Anti-clockwise, right? So this is the responsibility for rotation of PPL. If you see that if dextro and levo compounds, one compound is a dextro, its mirror image. If you say if a compound is dextro, then its mirror image could be can be levo. Dextrorotatory, and this is levorotatory. So it is very, very important, and vice versa. Right? So let us see that the previous slide. Here it is. If this half of the molecule is rotates dextro and this half rotates levo, so therefore this mutually cancelled each other. Plus theta, this is minus theta. Right? Net rotation is 0. And if you consider this object, these molecules, If this entire molecule rotates the ppl plus theta, and this is rotates the molecule opposite minus theta, right? Therefore, the net rotation is 0. That phenomenon is known as external compensation, and this phenomenon is internal compensation. Understood? Yeah. So calculation of specific rotation. So here it is, specific rotation. Specific rotation. Actually, it is measured at a constant temperature and a suitable wavelength. Suitable wavelengths. So actually we can mathematically express like this. So how do you express it is so it is called theta observed. It is called theta C is what? Concentration. Gram per ml. Is length of tube in decimeters. In decimeters. Right? This is a specific rotation. So this type, based on this, the questions may be asked you in a mains or advanced level, but EAMCET level we don't expect any questions from this. And next, representation of organic compounds. Representation. That means 3D molecules are projected. 3D molecules are projected in 2D plane 3D molecules are projected in 2D plane. So by following projections. Right. So here it is first. Let us take here Fisher projection. Fisher projection. And the second one is wedge dash. Newman's projection. So these three ways, usually we can represent 3D molecules on 2D paper. Okay. Right. So let us see here Fisher projection first. Projection. So what are the rules we can write here? Simple rules we can follow here. One is what? Long chain is taken on vertical line. Vertical line. And the second one. So groups at chiral carbon. At chiral carbon. Right, taken on a horizontal line. Right. And one thing you have to notice that the most oxidized group at the top, right, like this we can represent. So these three rules we should follow when you project that Fisher projection formula. Let me give example. Suppose example, if I write CH2H CHO to CHO. So there is a chiral carbon. So how do you represent this molecule? Vertical line. Like this. And at the top you can place most oxide. This carbon, 2 carbons we have. CHO we have terminal and CH2OH we have. Therefore CHO it should be top and CH2OH it should be bottom. And horizontal line. So one is a chiral carbon in the middle, therefore you can make like this, one is horizontal, right? So in which you can put H is left side and OH is right side. Even other possibility also we have. What is its possibility, other possibility? If you take its mirror image, like this, CHO, OH, H, this is CH2OH. So if you see, this is a chiral carbon, this is a chiral carbon, and these two are mirror images to each other. These two are mirror images. If you put mirror, so in the mirror, this looks like this. Yes. So the original image, it is original image. In this image, it appears like this. Understood? Yes. What exactly represent this object projection? So this projection represent groups. And number of stereo isomers you can write here. Number of stereo isomers is equals to, we can take 2 power n, where n is a number of chiral carbons. Number of chiral carbons. Right. Therefore, here one chiral carbon is there, number of isomers 2. So if one is dextro compound, as we discussed, one is dextro compound and other one is said to be levo compound. Dextro and levo. Right? Lokesh, sir, please in Telugu. ఓకే అమ్మా, నువ్వు నాకు ఎంత, నేను ఒకసారి చార్ట్ చూడట్లేదు సరిగా, ఒకసారి ఉంటున్నావు ఒకసారి వెళ్తున్నావు కదా, అందుకే నేను మొత్తం ఇంగ్లీష్లో చెప్తున్నా. ఓకేనా లోకేష్? రైట్, థ్యాంక్ యూ. సో డెక్స్ట్రో కాంపౌండ్ అండ్ లీవో కాంపౌండ్. లోకేష్, ఇక్కడ ఏంటంటే ప్రాబ్లము, కొన్ని టర్మ్స్ మనం తెలుగులో చెప్పినా కూడా అది ఇంగ్లీష్నే చెప్పాల్సి వస్తుంది. ఫరూక్, యా ఫరూక్ హౌ అమ్మా ఫరూక్? నేను ఏపీ నుంచి వస్తున్నా. పర్లేదు, సరే ఇక్కడ చూద్దాం. అయితే ఇక్కడ గ్రూప్స్ వర్టికల్ లైన్ మీద ఉన్నాయి. అంటే ఇక్కడ ఈ వర్టికల్ లైన్లో ఉన్న గ్రూప్స్ని ఏమంటాం మనం, ఎలా అర్థం చేసుకుంటాం అంటే, ఇక్కడ మీకు తెలుగులో ఎక్స్ప్లెయిన్ చేస్తాను. సో ఈ వర్టికల్ లైన్ పైన ఉన్న గ్రూప్స్ని ఏమంటారు అంటే, జస్ట్ ఇట్ ఈస్ 3 డైమెన్షన్. వీ కెన్ అండర్స్టాండ్ ఇట్ ఈస్ 3 డైమెన్షన్లో ఉన్న మాలిక్యూల్స్ ఇవి. ఈ 3 డైమెన్షన్ ఉన్న మాలిక్యూల్ ఏంటంటే మీనింగ్ ఈ గ్రూప్స్ అబౌవ్ ది ప్లేన్ అన్నట్టు. దీస్ గ్రూప్స్ హారిజాంటల్ ఉన్నాయి. వండర్ఫుల్ వంశీ. నో నో నో, ఏమైందమ్మా వంశీ? వంశీ వాట్ హ్యాపెన్? ఓకే, లెట్ us కంబైన్ తెలుగు అండ్ ఇంగ్లీష్. సో ఎలా అని మీరు అర్థం చేసుకుంటారు ఇక్కడ, వర్టికల్ లైన్ మీద గ్రూప్స్ అంటే గ్రూప్స్ ఆన్ వర్టికల్ లైన్. సో సో గ్రూప్స్ ఆన్ వర్టికల్ లైన్ అంటే నిటారుగా ఈ లైన్ మీద ఉన్న గ్రూప్స్ని వర్టికల్ లైన్స్ అవే అవే అంటే మనకు దూరంగా కనిపిస్తున్నట్టు ఇమాజిన్ చేసుకోవాలి. అవే ఫ్రమ్ వ్యూయర్. అండ్ గ్రూప్స్ ఆన్ హారిజాంటల్ లైన్ అంటే మన వాళ్ళు కదా ఉన్నది, తెలుగులో చెప్పండి సార్. ఓకే ఫరూక్ చెప్తాను, కాకపోతే ఈ లాంగ్వేజ్ అంటే టర్మ్స్ అన్నీ ఇంగ్లీష్ కూడా ఉంటాయి కదా. ఇప్పుడు లీవో అంటే దీనికి, డెక్స్ట్రో అంటే దీనికి ఎగ్జాక్ట్లీ మీనింగ్ తెలుగులో ఉండవు. ఇప్పుడు డెక్స్ట్రో అంటే ఎగ్జాక్ట్లీ దీనికి తెలుగులో మీనింగ్, లీవో అంటే తెలుగులో మీనింగ్ ఉండవు. కాకపోతే అంటే కుడివైపు డెక్స్ట్రో అంటే అంటే లైట్ను కుడివైపు తిప్పేటి. హలో హలో ఫహద్, ఇప్పుడు పీపీఎల్ లైట్ ఉంది, పీపీఎల్ను ఇవి ఎటు సైడ్ తిప్పుతాయి? తెలుగులో రాయాలంటే నాకు తెలుగు వచ్చు, కుడివైపు తిప్పుతాయి. కుడివైపు నాకు ఆఫ్టర్ మెనీ డేస్ ఐఎమ్ రైటింగ్ తెలుగు ఆన్ ద బోర్డ్. కుడివైపునకు తిప్పట, కుడివైపునకు తిప్పుట. ఈ కాంపౌండ్ ఎగ్జాక్ట్లీ ఏం చేస్తుంది ఇప్పుడు మనకి? సార్ యువర్ డస్ నాట్ గివ్. ఐ విల్ గివ్. ఎడమ వైపు తిప్పుతుంది. అంటే ఈ కాంపౌండ్ టెస్ట్ ట్యూబ్లో తీసుకొని మనం లైట్ పాస్ చేస్తే ఎటు తిప్పుతుంది? ఎడమ వైపునకు తిప్పుతుంది. ఓకేనా? ఇది కుడి వైపున తిప్పితే దాన్ని ఏమంటాం? డెక్స్ట్రో అంటాము. ఓకేనా? లైట్ను పీపీఎల్ లైట్ను ఎడమ వైపు తిప్పితే దాన్ని లివో అంటాం. ఓకేనా సార్? ఓకే, ఇంగ్లీష్ అని తెలుగు, రైట్ రైట్. సరే చూద్దాం, రెండు కవర్ చేద్దాం, ఎందుకంటే ఆల్ స్టూడెంట్స్ ఉన్నారు కదా. రైట్. ఇప్పుడు గ్రూప్స్ ఆన్ వర్టికల్ లైన్ అవే ఫ్రమ్ వ్యూయర్ అలా అర్థం చేసుకోవాలి మనం. అంటే ఈ వర్టికల్ లైన్లో ఉన్న గ్రూప్స్ అన్నీ మనకు అటువైపుకు ఉన్నట్టు, బ్యాక్ సైడ్ ఉన్నట్టు. ఇప్పుడు ఈ గ్రూప్స్ హారిజాంటల్ లైన్స్ ఉన్నాయన్నీ మనకు క్లోజ్గా ఉన్నట్టు, అలా ఇమాజిన్ చేసుకోవాలి. గ్రూప్స్ ఆన్ హారిజాంటల్ లైన్ క్లోజర్ టు వ్యూయర్. సార్ నేను ఓన్లీ యూట్యూబ్లో చదువుతున్నాను, జేఈ మెయిన్స్ పాస్ వచ్చా? వై నాట్ అంటే ఎక్కడైనా అమ్మా నువ్వు ఏ దాంట్లో చదివినా కూడా ప్రాబ్లం ఏంటంటే సీరియస్నెస్ మోస్ట్ ఇంపార్టెంట్. ఆ సీరియస్నెస్ అనేది ఉండాలి. జస్ట్ కమిట్మెంట్ ఉంటే సరిపోతుంది అంతే. నువ్వు ఎక్కడ చదివినా ప్రాబ్లం ఏంటి, అది నీ వైపు నుంచే ఉంటుంది. ప్రాపర్ గైడెన్స్ కూడా ఉండాలి. ప్రాపర్ గైడెన్స్, ప్రాపర్ ఇన్పుట్ ఉంటే నీకు ఆటోమేటిక్గా గెట్ ఆన్ అవుతావు. ఫరూక్ కానీ నువ్వు టచ్లో ఉంటుండు, నీకు ప్రాపర్ గైడెన్స్ ఇస్తాను నేను. ఐఎమ్ స్టడింగ్ ఇన్ ఓన్లీ ఇన్ ఫిజిక్స్ వాలా అండ్ Unacademy. Yeah, that's okay, but you should utilize properly. ఉమ్. ఇప్పుడు ఇది స్టార్టింగ్ యూట్యూబ్లో స్టార్ట్ చేసాను, రీసెంట్గా స్టార్ట్ చేశాను క్లాసెస్. మీరు రెగ్యులర్గా ఫాలో అవుతుంటే నేను రెగ్యులర్గా అది నెంబరు షేర్ చేయలేను ఫరూక్, నెంబర్ షేర్ చేయలేను నేను, ఎందుకంటే దట్ ఈస్ ఎగెనెస్ట్ టు పాలసీ. ఓకేనా? అందుకే నా నెంబరు షేర్ చేయలేను. ఒక వీలైతే మాత్రం నేను ట్రై చేస్తాను. ఒకవేళ పాలసీ లేదంటే మాత్రం మీకు ట్రై చేస్తాను. ఓకే. ఓకే ఓకే లోకేష్, డెఫినెట్గా బెటర్ టు షేర్ యువర్ నెంబర్. So because actually I should not reveal that my number and my personal details. That's what. ఓకే, సరే ఈ రోజుకు మనం స్టాప్ చేద్దాము. నెక్స్ట్ క్లాస్లో కంటిన్యూ చేద్దాము. ఏది ఇక్కడ వరకు ఆగాం మనం అంటే ఫిషర్ ప్రొజెక్షన్లో ఉన్నాము. ఫిషర్ ప్రొజెక్షన్లో ఎలా రిప్రజెంట్ చేస్తాం ఆబ్జెక్ట్ అనేది, 3D మాలిక్యూల్స్ ఎలా డిస్కస్ చేస్తాం అనేది చూద్దాం. ఓకే, ఇక్కడ వెడ్జ్ డాష్ ఉంది, న్యూమన్ ప్రొజెక్షన్ ఉంది, అవి నెక్స్ట్ క్లాస్లో మనం డిస్కస్ చేద్దాం. సో ఈ రోజుకి మనం స్టాప్ చేస్తున్నాం క్లాస్. ఓకేనా లోకేష్ అండ్ ఫరూక్, ఫహద్, వంశీ and other students also. So we'll stop today. Anyhow, you will get notice with you will get message of my class. So just to you join tomorrow's class, you will continue this rest of the topics. You know? Can I stop now? Yes.